Hey guys, so I'm back after like 1.5 years. Now I'm ready to actually start uploading to this channel again. So I have some new content I want to do, so let's just get right into it, right? So the problem we're going to be looking at today is the third problem of the 2019 US Open Bronze Contest, Cow Evolution. And from here on out, I'm just going to assume that you've read the problem. So if you have not, now is when you pause the video and just go check it out. And alright, let's just get right into the solution. So if you don't understand the problem, it's essentially giving you a family tree of sorts, and it's asking you if it's a possible family tree to make. Right, so let's look at their diagram and it'll be a little bit more clear. So when we first start off the tree, we just have an average old cow here, right? Nothing special, just a cow. But then this cow eventually has some descendants, and they've evolved to have some interesting traits. So one of its descendants is this one right here, right? And it now has spots. But sadly for the other dude, he kind of got left out, right? He's just still a normal cow. But now we have two layers of our tree. Eventually, the guys on the bottoms will have their own descendants, right? So the cow with the spots descendants now have fire breathing. The other normal cow's descendant now has two of its own descendants. One of them got unlucky again, and he's just a normal chump, but his other descendant can now fly. Right, so cool. Now we have another layer of our tree, and we have one more to go. So you know the drill. Bottom layer cows eventually, they have their own descendants, and in this case, only the flying one has some descendants. One of them got telepathy, so now we have a flying telepathic cow, and the other one got nothing. But since his parent could fly, he's still just a flying cow. So now if we look at it, we have an evolutionary tree, right? So then what this problem does is give us a description of this tree, and we have to see if we can actually make a proper one. Right, so let's look at the sample input. What it's doing is just describing each of the latest descendants in our tree. So for our sample input, it's actually describing the tree we just made. Right, so if we just look through the sample input, the first line is describing our cow on the far right, which has fire breathing and spots. The second line is describing the cow on the far left with no traits. The third line is describing the cow on the middle left with only flying, and the fourth line is describing the cow on the middle right with flying and telepathy. And again, what we want to do is see if this creates a proper tree. And what exactly even is a proper tree, right? So a proper tree, according to the problem, is where each trait only originates in one cow. In other words, it's not proper when the same trait randomly develops in different cows. So for example, this tree right here, this would be improper because both the cows on the bottom branch both have spots, even though their parents don't have spots, which means they both had to randomly develop spots. Alright, so now that we understand this problem, let's think a little bit for how to solve it. So if we think a bit about how to prove a tree will work, we might realize that, it's actually could be easier to figure out when it doesn't work. Because the problem literally tells us what makes it not work when two cows randomly develop the same characteristic. So now we have to find out what cases will have both cows develop the same characteristic. So let's see how to find this out. Let's look at this really simple tree for a second, right? So just three cows, the bottom left one has fire breathing and the bottom right one has spots. So what if the spotted dude has two descendants? One has fire breathing and spots, and the other one has telepathy and spots. Like, wait a minute, what? How is this possible? And the answer is it's not. The telepathy and the spots is perfectly fine, but the fire breathing and spots, oh no. The two ways a cow could have gotten both fire breathing and spots is that he either randomly developed it or he inherited it. He obviously didn't inherit it because his parent only has spots. And if he randomly developed it, that means that the tree is invalid because the cow on the left already developed fire breathing. So now that we see that, okay, this is one way to see if our tree is invalid. Are there any more? And after a bit of testing, you'll find out that no, this is all you have to consider. So what we want to see is that if for some two characteristics, A and B, right, so just any random characteristics, that if we can find a cow that has A but not B, a cow that has B but not A, and a cow that has both A and B, then it's impossible. To break that down, if we can find a cow that has trait A but not trait B, and a cow that has trait B but not trait A, this must mean that we have two separate branches, right? Because if either cow descended from the other one of them would have to have both A and B. So if we can find that trait A and trait B are on different branches, then if there's a cow that has both A and B, that means that the cow had to have randomly developed either A or B, meaning that our tree is invalid. So let's think about how we'd implement this check. So to check for each combination of characteristics A and B, we'll need a nested for loop, both loops going through all the characteristics. This is fine though, since n is at most 25, meaning we can actually use 4 nested for loops, right? So anyway, for each of these combination of characteristics A and B, we need to check if we can find a cow that has A and not B, one with B and not A, and one with both A and B. So we'll have to loop through every cow and check all of its characteristics as well, giving us another 2 nested for loops. So this gives us a total of 4 nested for loops, which, since n is only 25, will run in time, right? So now that we see how this will work, let's just go ahead and get to coding it. Okay, so I'm going to be coding this in C++, but if you don't use C++, that's okay. You will hopefully still be able to follow along. And what we're going to do is just open up a CPP file in our favorite IDE, and I'm going to be using Genie, but you can use whatever you want, right? So I'm just going to copy paste in my includes and whatever, right? So what I do is use include bits/std_c++.h, which, if you don't know, is just basically a giant collection of a ton of includes, and it's easier to just do this every time instead of figuring out what stuff you have to include, right? And our setIO function, which basically just does our opening the .in and .out files along with this line right here, our iOS base, sync with Studio and whatever, which is just like making our IO faster, input output faster, right? So I would recommend you guys to actually use this thing, and you can just find it on any recent solution for USACO. You can just go to like some random platinum or gold solution and you'll probably find this. You can just copy paste it in. Right, so what we're gonna do, we're just gonna start off with defining some things, right? So we have our int n, and then we'll also need a vector of strings to hold our cows. So if you look at the input, right, so an array of vector of strings, So for our sample input, we can have an array of length 4 of vector of strings to basically store each cow's characteristic. So vector string and cows 30. Right, so the reason we have 30 is because the maximum n possible is 25. And then let's just do 30 just in case. You never know. So then one more thing, we want to have a vector of string called all characteristics. And the reason we need this is because, if you remember, we have to check for all pairs of characteristics A and B. So we're going to need to know every characteristic that's available. Alright, so what we're going to do now, we can just go ahead and create our int main. And then first things first, we want to call setIO cow evolution, I believe. Nope, it's just evolution. Right. So we want to open up our .in and .out files, and then we can just do our inputting, right? So with setIO, it just maps cin to whatever in file, so we can just do cin, right? So we get n, and then let's see, we also need to define an int num and string characteristic, and we're just going to use these while we're inputting. So for int I equals 0, I is less than n, I plus plus. So we're going to cin num, and then this will be how many characteristics our current cow has. And then for int j equals 0, j is less than num and j plus plus. So now we want to see in characteristic. And that's obviously just what characteristic our cow has. So we're just going to go cows of I. So we're on the ith cow dot push back characteristic, right? So we're going to give our cow that characteristic, and then we also want to put it into our all characteristics, but we also don't want to have duplicates. So we can just use our C++'s inbuilt find function. We're going to go find all characteristics dot begin, all characteristics dot end, and we want to find characteristic, and then if this equals all characteristics dot end, that means we did not find characteristic in all characteristics, which means we can go ahead and put it into our vector. So all characteristics dot push back characteristic. Okay, and hopefully I did not misspell anything. Anyways, so now what we want to do is move on to our second step, which, if you remember, is going to be checking for each pair and every possible pair of characteristics A and B. If some cow has A but not B, some cow has B but not A, and some cow has both A and B. So to get all of the pairs of characteristics, obviously what we're going to do is just loop through all characteristics. So we can go for int I equals 0, I is less than int all characteristics dot size and I plus plus. Right, and what we can do now is for int j equals I plus 1, j is less than int all characteristics dot size j plus plus. So then this will actually give us all possible combinations of characteristics. And the reason we can do j equals I plus 1, because if you set j equals to 0, it'll check, like, say I equals 0 and j equals 1, and it'll also check j equals 0 and I equals 1. And it'll take those as different combinations, even though it's like A, B, and BA, which is obviously the same. So if we just set j equals I plus 1, it will actually give us all pairs without duplicating anything. Right, and then if you don't know, we have this int here because all characteristics dot size is actually an unsigned integer versus our j, which is a signed integer. So it'll just give us a warning if we're trying to compare an unsigned and a signed integer. And now what we want to do is check for these combinations I and j if we can find, if you remember, cow with I but not j, a cow with j but not I, and a cow with both I and j. So what we're going to do, we're going to put this into a function, right? So we can go bool, we'll just call it check. And then let's go int, we can pass in, so string A and string B, right, for our characteristics A and B. No, actually, it makes more sense to go int A and int B. Okay, so now, remember? So we're just going to define our initial booleans. So remember, we need A but not B, B, oh, and we set these all equal to false as well. B but not A, and that's false, and both. And we'll set this equal to false as well. Okay, so now we want to loop through all cows and check if we can find this characteristic. So we're going to do for int I equals 0, I is less than n, I plus plus. So we're going to loop through all of our cows, and then bool has A equals false, and bool has B equals false. So we want to check if this cow we're on has A and it has B. So what we can go ahead and do is loop through all of this cow's characteristics. So for int j equals 0, j is less than int all, or not all characteristics, cow's I dot size and j plus plus. So we can just very simply go if cow's I j, so this is whatever characteristic we're on, equals all characteristics A. So if this cow has the characteristic A, then we can just go ahead and do has A equals true. And then we can do the same thing for B. Might as well just copy paste it here, command control C, control V, and then change our capital A to capital B and capital A to capital B. So now, once we're done with this loop, we'll know if our cow I has characteristic A and if it has characteristic B. So what we can go ahead and do, if has A, and not has B, so this means we have A but we do not have B, then that means we're gonna do A not B equals true. And then if has B and not has A, then B not A equals true. And then lastly, if has A and has B, we're gonna go ahead and go both equals true. So once we're all the way done with our for loops, we'll know if we found a cow that has A but not B, if we found a cow that has B but not A, and if we found a cow that has both. So if you remember, we want to return false if all three of these are true. So we can go if A not B and B not A and both. Then we can go ahead and return false. Otherwise, we just return true. Right, and that's the end of our check function. So what we can actually go ahead and do here is just call it. Okay, so we're just gonna go if not check ij, because our goal is to figure out if something is impossible, right? So if check returns false, that means we know it's impossible. And if we know it's impossible, we can just print no and return, right? So we just go cout no endl and then return 0, right? So now if we got all the way past every single possible characteristic, then that means the answer would be yes and endl. And we can go ahead, Control S, and build. Let's see, all right, no errors. So what we can do, we can open up a .in file, cal_evolution.in. Oh wait, it's supposed to be evolution, isn't it? I'm gonna go ahead and open evolution.in. Okay, and then let's just copy paste our input data. Control C and Control V, Control S. And then we can just run cal evolution and then look at our out file. And it tells us yes, and it's true. All right, so it fits our sample data. So we can go ahead and just check if it works. All right, so as I was saying, we can go ahead and check if it works. So let's go choose file and src USACO cal evolution and cal evolution.cpp, and let's just submit it and see what happens. All right, so looks like it works. So yeah, that's basically about it. Well, so I hope you guys enjoyed this video. First time I've done a bronze tutorial, so let me know in the comments if you liked it, if you have any feedback, or whatever other stuff you want me to do. Anyways, don't forget to subscribe if you love the content, and you can head over to callandcodingclass.com if you actually want to take a bronze class from me or any other coding class. We're going to be opening up a lot more very soon. Right? Anyways, so thanks for watching, and I'll see you guys in the next one.